Hello Chobham students, this is Mr. Butcher with a quick exam walkthrough. Just one question this time, but there will be many more on the way. Okay, so in a recent assessment, you were asked to imagine that you want to investigate the ideas of Priestley and Lavoisier. You were told to assume that you've been given three pieces of different metals. Typically in a lab, the metals are heated to high temperatures in crucibles. So you have been provided with an image there of a crucible. I've added in the metal there, and of course every crucible will have a lid. In a lab it won't be expected to just float there. You'll place it on top of a tripod and gauze, and that'll be over a Bunsen burner, and of course we'd have difficulty breathing unless in the lab we also had some air. And just so you are aware, the Bunsen burner, even though that might not have been the exact thing that Priestley and Lavoisier were using when they were investigating this idea, that is what's going to provide us with a high heat or high temperature. And of course, as we're using that Bunsen burner, we need to be safe. So there is our heat-proof mat. Now, this metal is heated in a crucible, and then of course, what will happen is it will turn into a metal powder, as Lavoisier and Priestley were suggesting. Now, in terms of what we needed to do, well, the question here is saying that there are metals, so that's plural there. So let's take three fictional metals, that's A, B, and C. And they were heated until they were a powder. And Priestley thinks that they would lose something to the air. So it's got the crucible lid on, and Priestley thought that it would still lose something to the air. And the opposite was said by Lavoisier, who said that they would gain something. Now, the only way to find out if something is gained or lost is to know exactly what they started with. So, if you measure out, let's say, 5 grams of a metal, and you place that inside your crucible, we can then see what happens after it's been heated to a high temperature. Now, if our results at the finish, so that's after we've heated it for a sufficiently long amount of time, we find that the mass is, as I've given you in the example here, increased. Then, of course, we have a gain of mass in each of those cases, and this will provide evidence that Lavoisier was correct. So, how does this help you with the exam question? Well, most of the information that I provided you with here was already there in the exam question. Here is the exam question, and you're asked then to produce a plan, and it actually gives you quite detailed bullet points as to what should be in that plan. And what I'll show you is that these bullet pointed parts of your plan here are the same as the 4 marks that are available for the question, and you should have come across these variables before. So the first one, what you change, that's your independent variable, and then one thing that you observe or measure, that's your dependent variable, and then the factors you would keep the same as you carry out your investigation. They're your control variables. Now, you may have previously called this fair test, or to keep it a fair test, but the right terminology for you to use now is control variables, and those are the things that you keep the same. The last marking point for this question is you need to state what evidence is needed to support Lavoisier's idea. So, have a little think based on what I discussed about the practical before, and see if you can work out what those 4 marking points would be. So, what would you change to carry out your investigation? What would you measure to collect your results? That's your dependent variable. And what would you keep the same so that you are only assessing the independent variable, and your dependent variable isn't based on the fact that you have changed things and done everything very randomly. The last thing then, what result would provide evidence that would support Lavoisier's idea? You can pause now if you want to have a go at those. Otherwise, I'll go on to the next slide. So, you could have said, for the first one, I would change the type of metals used, and this is because Priestley and Lavoisier, in their ideas there, they say metals, which is plural. So they're saying that all metals, when they burn in air, either lose or gain something. The dependent variable would have to be the change in mass before and after burning, which is heating. And then, of course, you've got the control variables. Now, you could have said quite a few different things, but heating all metals to a high temperature, keeping the lid on, heating until no more mass is gained or lost, same starting mass of metal, same air, of course, in the lab, and the same crucible used. And the last thing we've already discussed, evidence to support Lavoisier would be that the mass has been gained in every metal, therefore we have that evidence to support Lavoisier's idea. So, just to summarise, if you get all the marks, you've demonstrated the following: ability to interpret scientific ideas, that's Lavoisier and Priestley's, and then turning that into a practical. Ability to justify and create instructions, so that is to say what you picked for your independent, dependent and control variables, and also ability to make judgments based on evidence. So you stated then what evidence would be required to support Lavoisier being correct. Thank you very much for listening.